Okay, so you should have opened up the key and you should have marked it up. I just wanted to walk through the key with you a little bit to make sure, because there are a couple things that you may have questions on, and I'm just going to try to answer those here. Okay, so for number 1 and number 3, it doesn't matter which order you wrote these elements. You could have put argon first and neon second and et cetera, et cetera. It doesn't matter what order these were written in. They would still be correct. So what do you notice about the location in the elements in number 1? They are in a column, and a column is what's going up and down in the periodic table. So these guys are all in a family, and they are in actually the family called the noble gases. So they're at the very far end of the periodic table. So number 3, again, could be in any order. And number 4, they were all in a column or family as well. Okay, so what do you notice about the number of valence electrons? Remember, valence electrons are in the outermost shell of the Bohr model. As you move from left to right across the row in a periodic table. So they increase by 1 in each family. So you should have seen that nitrogen has, oops, I'm not seeing my pen here. Okay. So that nitrogen has 1 valence electron, and magnesium has 2 valence electrons, and aluminum has 3 valence electrons. So that's what we mean by they increase by 1 in each family. All the way over to the noble gas, and you should have noticed that the noble gas has 8 valence electrons for that one. What do you notice about the number of energy levels or shells as you move down a periodic table? And this is one of the questions that we asked last chapter. If you notice that as we go down each row, we go into another energy level or shell. So if you're in the second one, your valence electrons in the second row, your valence electrons will be in the second shell. If you are in the third row, then like sodium, then your valence electrons will be in the third shell. Perfect. Okay, so elements are organized into families according to their physical and chemical properties. Identify the elements that you used in step 5 that belong in each family based on the number of valence electrons. So give the name and symbol of each element. Again, these could be in any order. So lithium and sodium, beryllium and magnesium have 2 valence electrons, et cetera, et cetera. And here, usually for the alkali metals, there is some confusion. What about hydrogen? Well, you notice that it says alkali metals. Is hydrogen a metal? Look and see what kind of element hydrogen is. What does it look like? What's its state of matter? Okay, so you should see that it's a gas, right? And metals, as you know, are solids at room temperature at least. So it really doesn't fit with the alkali metals, but it does have 1 valence electron, so you may have drawn it here. However, it doesn't really fit there. That's one of the ones that probably would have thrown you off. You're having questions about that one. Okay, so number 8. What do you notice about the location of the elements in each family? These are all in the same column. And how would you classify hydrogen and why? So it would be in the first column. We kind of said this already, because it has 1 valence electron, but it's not a metal. So it doesn't really fit anywhere. So that's why poor hydrogen didn't get a color, because he's kind of an oddball. He doesn't really fit with the alkali metals, but he has 1 valence electron. So he does fit in that column for sure. Okay, so hopefully you have noticed this, that 1 valence electron is in the first row. 2 valence electrons, sorry, in the first family, and 2 valence electrons in the second family. And then when you look at the other families, the boron family is actually number 13. So if you look at the ones place, you will see that family 13 has 3 valence electrons. Family 14 has 4 valence electrons. So when you look at number 10, this is the other rhetoric question here, trying to get you to go a little bit beyond, figure this out for yourself. So if you looked at barium, that is in family number 2. Everybody in family number 2 has 2 valence electrons. How cool is that? And lead is in family 14, so that has 4 valence electrons. Xenon is in family 18, it's a noble gas, and it has 8 valence electrons. And potassium is an alkali metal, and that one has 1 valence electron. So on this one, like I said, this will be a completion grade, so you do not need to write a number correct out of a number possible. I just want to look at how you marked it up, how you caught on to these, if you caught on to these ideas and concepts, and how well that went for you. Okay, so hopefully this went well, and we'll talk to you later. Have a great day. Oops.